Many of our clients already use Lucis for analysis on their retaining wall, dam, wind farm or tunnelling projects. Applications like these typically require a more comprehensive model of the soil or geotechnical conditions than some other projects might. Lucis has a range of tools which these clients tend to use, from springs through to continuum modelling with non-linear soil materials, and contact joints, slide lines, stage construction tools and special soil interfaces. Lucis version 19 includes some new facilities which have been developed with these and further soil applications in mind. The Phi-c reduction method gives a safety factor based on, as the name suggests, a soil strength reduction analysis. The factor indicates how the available soil strength compares to the soil strength required for equilibrium for a given set of loads. It's typically used for slope stability or retaining structures. Whatever the situation, it's always as simple as defining and assigning a Phi-c reduction attribute. And when the analysis is solved, the cohesion and the internal angle of friction will be decremented proportionally until failure in order to determine that factor of safety. In this analysis, the use of 3 Phi-c attributes allows us to consider the safety factor on the slope at 2 different stages of construction plus the wall independently. This ensures that we will finally obtain a factor of safety for both the wall and the slope, not just one factor of safety relating to whichever of the two happens to have the lower factor. Now, since version 15, our analysis tree on the left here has made it easy to consider different analyses relating to the same model, such as the construction sequence with best estimate soil parameters, but to compare with the same analyses using upper and lower bound parameters. Again, comparing against perhaps a completely different construction sequence, or considering consolidation, and more analyses to suit project requirements, each taking into consideration different assumptions as needed, such as different material properties or support conditions. What's new is the ability to insert branches from any stage in a construction sequence. That could be a Phi-c reduction branch. Adding several such branches allows us to check soil stability at multiple stages through the sequence. Or we could add an alternative construction sequence branch, that is, a different ending with the same beginning. Or a consolidation branch at a particular stage or stages. Or we might wish to consider a stage as being drained rather than undrained. We can even add a transient dynamic analysis branch, such as a seismic event, affecting the model partway through the sequence or at the end of the sequence, with all the prior stress state inherited. Indeed, practically any analysis type can be a branch. And if you modify a branch, Lucis doesn't need to rerun the trunk analysis, so it's time efficient as a facility too. Well, here I've touched on consolidation, the equalization of pore water pressure with time, which might be associated with all sorts of natural or construction events, including dewatering. But in essence, it's the path between the undrained and drained conditions, which are so essential in soil mechanics, since both the stiffness and the strength of soils depend upon effective stress. And Lucis has been capable of consolidation or seepage type analysis for a very long time. However, now we have a shortcut from the undrained to the drained condition. This removes the need to explicitly model pore water pressure changes. With the assignment of one attribute, we can obtain the alternative response, with drained conditions typically being critical for cuttings, excavations or retaining walls where soil loads are being decremented. But in all these analyses, of course, the workhorse is the constitutive material model. On the Attributes Material Geotechnical menu, you'll now find listed our range of geotechnical materials. Amongst them, the familiar Moore-Coulomb and modified Moore-Coulomb with the tension and compression caps. The Cam Clay material released in version 16, Duncan Chang released in version 17, and now the Hoke-Brown material model, which describes the behaviour of rocks, both intact and fractured. It's a elastic, perfectly plastic material with a yield surface which is a curved hexagonal cone. There are options for the definition of strength parameters and the flow rule, including a transitional option. In common with the other soil materials in Lucis, the material can be made two-phase, where hydraulic conductivity can be defined as required, and when partial saturation is selected, draining and filling curves can be specified. Finally, an easy-to-use K0 initialization is available for this material, as it has been for the other soil materials since version 17. This version does, however, bring a few additional K0 options for the existing CAM clay material. The Hope Brown material here can be used in any static, stage construction, dynamic or consolidation analysis in Lucis, just like the other geotechnical materials. And, along with both of the more Coulomb materials, it can be used in the new Phi-c analysis branches. The trusted Lucis tools are extended in this version, with more facilities particularly aimed at geotechnical analyses. We hope you'll see more and more applications for Lucis on your projects, and we hope you'll enjoy using Lucis version 19.